Hello dear learners, today in this video I am going to solve question number 4 of your exercise 8.2. So the question number 8 is that ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F, so that F is the midpoint of BC. We are given ABCD is a parallelogram in which this side AB and this side DC, these two sides are parallel. It is given in question. Also, BD is the diagonal and E is the midpoint of AD, and through E a line is drawn parallel to AB. A line is drawn parallel to AB intersecting BC at F. E is the midpoint of AD, and through this E a line parallel to AB is drawn such that it cuts BC at F. We need to prove that this F is also midpoint of BC. We are given E is midpoint of AD. Now we have to prove that F is the midpoint of BC and EF is parallel to AB. Suppose this intersecting point is G. So first of all we have to write what are given. In trapezium what is given? In trapezium ABCD, AB is parallel to DC, E is the midpoint of AD and EF is parallel to AB. These things are given in question. We need to prove F is the midpoint of BC. That is, this F is midpoint of BC. That means BF and CF are equal. We have to prove. So let's start. Proof. In proof section, first of all see, in this triangle ADB, in triangle ADB or ABD, whatever you give the name, ADB is the midpoint, no? E is the midpoint and EF is parallel to AB. So EZ will also be parallel to AB because parts of parallel lines are parallel. Yes or not? First of all, right? EF in triangle ADB, E is the midpoint. E is the midpoint of AD and EZ is parallel to AB. In triangle ADB, E is the midpoint of AD and EZ is parallel to AB. Why EZ is parallel to AB? Because EF is parallel to AB and EZ is the part of EF. We know that parts of parallel lines are parallel. This is the part of EF. EF is parallel to AB, so EZ is parallel to AB. So we can write in triangle ADB, E is the midpoint and AD. We know that when a line parallel to third side in a triangle, when this line joins the two midpoint, in the theorem, midpoint theorem, we got it that line joining by two midpoints of a parallel, two midpoints of two sides of a triangle is parallel to the third side. Since in this case EZ is parallel to AB and E is the midpoint, so C must be a midpoint. Yes or not? So we can write, therefore we can write Z is the midpoint. Z is the midpoint of BD. Why? You can give the reason here. So what reason? Line segment through the midpoint of and parallel to another side pass through the midpoint of other side. Line segment through the midpoint and parallel to another side. This line segment passing through midpoint of E and is parallel to AB will pass through midpoint of other side, that means this side. So G is the midpoint. So since G is the midpoint, now see, given EF is parallel to AB. EF is parallel to AB. Again DC is parallel to AB. It is also given DC is parallel to AB. Since EF is parallel to AB and DC is parallel to AB, therefore EF and DC are also parallel. EF is parallel to DC. That means this EF is also parallel to DC. If EF is parallel to DC, then GF is parallel to, therefore GF is parallel to DC. Yes or no? EF is parallel to AB, DC is parallel to AB. So EF is parallel to DC because they are parallel to same line. Lines parallel to same lines are also parallel. So these are the line segment or sides parallel to the same side, so they are also parallel. Since EF is parallel to DC, EF is parallel to DC, that means GF is also parallel to DC because parts of parallel lines are parallel. Yeah, EF is parallel to DC, so GF is parallel to what? DC. Now see, if we consider this triangle now, BDC or DBC, whatever you consider, in BDC triangle, G is the midpoint of BD and this is parallel to this side DC. That means a line passing through the midpoint of one side and this line is also parallel to another side, so it will pass through the other side, midpoint of other side also, just like before in triangle ABD. We prove a line was passing through a midpoint and it is parallel to AB, so G is the midpoint. The same case arises here. G is the midpoint and this line segment is parallel to DC, so F is the midpoint. So in triangle in triangle DBC, G is the midpoint. G is the midpoint of BD and GF is parallel to DC. Therefore, we can write F is the midpoint. F is the midpoint of BC. That's it. Now we'll solve question number 6. Question number 6 is that show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. Line segment joining by the opposite midpoint of opposite side. Suppose midpoint of AB is Q and midpoint of BC is Q, midpoint of CD is R and midpoint of AD is S. We need to prove that the line segment joining by the midpoints of opposite sides. So opposite side of AB is DC and these are the midpoints of opposite sides. So this line segment PR and this line segment SQ bisect each other. That means this part, suppose this point is G, this part DRG and PG are equal and QG and HG are equal. We need to prove this one. So for that we will connect this line, connect these things, this portion, this and this, and we have constructed this one is joined, AC is joined. It is not necessary that AC will pass through G because G is extra point and AC is the diagonal, so it is not necessary to pass AC through G. So let us consider a quadrilateral ABCD in which in which P, Q, R and S are the midpoints of AB, BC, CD and DA respectively. Respectively. To prove what we need to prove, that these two line segments PR and PQ bisect. That means part PG is equal to, here we need to prove PG is equal to GR and SG is equal to GQ. These two things we need to prove. So construction, what we have constructed in construction we have joined AC. A and C are joined. A and C are joined. Now see, in triangle, suppose in triangle ADC, proof. In triangle ADC, S is the midpoint of side AD and R is the midpoint of side DC. So we can say that SR is the line segment joining by this midpoint of these two sides, this triangle ADC and this triangle. In these two triangle, R is the midpoint of DC and S is the midpoint of AD. We know that line segment joining by the two midpoints of two sides of a triangle is parallel to the third side and half of the third side. So we can say that in triangle ADC, S and R are the midpoints of AD and DC. No? Therefore, what can we write? We can write therefore the SR is parallel to AC and SR is equal to half of AC. No? From where we get it? From midpoint theorem. You can write from midpoint theorem of triangle. No? Midpoint theorem of triangle, we can write this because SR is parallel, so these are the midpoints. So line joining by the midpoints is parallel to the third side. AC is the third side and half of AC third side. So similarly we can write in triangle ABC we can write PQ is parallel. So in triangle ABC, P is the midpoint of AB and Q is the midpoint of BC. So this is the line segment joining by the midpoints of two sides of this triangle. So it is parallel to AC and half of AC. So PQ is parallel to AC and PQ is equal to half of AC. This is equation number 2. So PQ is parallel to AC and PQ is half of AC. From equation 1 and 2, what we get from 1 and 2? Now see, from equation 1 and 2 we get that SR is parallel to AC, PQ is parallel to AC. Therefore SR and PQ are also parallel. So we can write from 1 and 2, SR is parallel to PQ and also SR is equal to half of AC and PQ is equal to half of AC. Therefore we can write SR is equal to PQ. Why? Because from Euclid's definition, axioms or postulates, we get that things equal to the same things are also equal. Since SR is equal to half of AC, PQ is equal to half of AC. So half of AC is the same thing. So these are also equal. Now see, in quadrilateral PQRS, in PQRS, SR and PQ are parallel, and SR and PQ are also equal. We have proved it. SR is parallel to PQ and SR is equal to PQ. And we know that if in a quadrilateral one pair of opposite side became equal and parallel, then that quadrilateral becomes a parallelogram. Therefore we can say that, therefore we can write, therefore PQRS is a parallelogram. Parallelogram. And we know that the diagonals of a parallelogram bisect each other. And here see, in parallelogram PQRS, PR and SQ are the diagonals, and we know that diagonals of a parallelogram bisect each other. This is the one property of parallelogram. First of all, we have proved that PQRS is a parallelogram. Since PR and SQ are diagonals of PQRS, so they will bisect each other. So we can say that PG is equal to ZR and SG is equal to ZQ. That's it. So you have to write therefore we can write PR and SQ bisect each other. Why? Because diagonals of a parallelogram, I am writing in short form, parallel sign and parallelogram bisect each other. If they bisect each other, then we can write PG is equal to ZR and SG is equal to ZQ. It is proved. Therefore PG is equal to ZR and SG is equal to ZQ. That's it.